All right, so today is the 25th of July, and we're talking about regression and also correlation and also a bunch of other stuff. So what I'm going to do is I'm going to have you connect with your friends and neighbors around you for just a minute and see if you can get all the information you need from them, just in case some of you might have the right answers and want to share them with people around you. Okay, so I'm going to give you about 5 minutes. Let you do that, and I'm going to hand back a few things that I graded while you're doing that.
This is exam 5. Oh, the old. Yeah. Oh, no, this is exam 5. This is 5, so this is not the last one we did. Yeah, this is 5. This is not the last one. I remember. I use the same. I feel like I'm going to which one is like standard deviation, like equation or other equation. For the standard deviation. Part 4. Thank you.
Here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6.
Me too. I'm Monday, Wednesday, and Friday. Thursdays, I only have class from 11 to 12.
6, all right. All right, there we are. We got everybody here today that's here, so that's what we want. So we need to talk through our concepts here. So what's the purpose of What does that mean?
What to expect.
What does that mean?
If it's below 5% is no. Above that, 95% yes.
What's the process of statistics? Someone other than Sierra.
Using a sample to understand population.
Okay, you use the sample to understand population. So someone other than Jessica, what are the two methods that we use for that? Hypothesis testing. What else? Confidence interval. It's like that second word just doesn't quite make it out, but yeah, confidence interval. What is the purpose of hypothesis testing?
Prove a difference.
Prove a difference. What's the purpose of a confidence interval?
Just for the measure of the population.
Yes. To measure the population. So we want to apply this to our particular situation where we're dealing with ordered pairs. Which is a set of X and a set of Y. And so in order to make this work, we're going to ask two questions. And those are going to correspond to the idea of correlation first. What is correlation saying? Or what is it asking? What question is it asking?
Is there a linear relationship?
Is there a linear relationship? And how do we go about asking that or answering that question?
You mean with the hypothesis test?
We use the hypothesis test, that's correct. Okay, so somebody other than Emily, tell me, what does that hypothesis test look like?
The null hypothesis would be P equals 0.
No, it's not P.
No.
It's rho equals.
I wasn't here that day, so.
Okay, so we'll, okay, who can tell me why I had to apologize for that?
Because statistics make similar symbols for things.
Yes, statistics make similar symbols for things. It looks like a P, but it's not a P. It's a rho. It's the Greek letter rho. Why would it be the Greek letter rho? What does it actually stand for? Nope.
Population.
Nope. What is the letter? Almost, but not quite. What does it stand for? What's the meaning of the symbol rho?
Population correlation.
Population correlation. So it doesn't seem to make sense to use an R or a rho for that, but that's what we use. We use a rho. This is the population correlation. What does the letter R stand for? This is the sample correlation. The null hypothesis is that rho is equal to 0. What's the alternative hypothesis?
Rho's not equal to 0.
Rho is not equal to 0. Are we using the process of statistics? Yes. We are using the sample to understand the population. I don't know the population correlation, but I do know the sample correlation. But what I'm going to try to do is use the sample correlation to prove something about the population correlation. And I'm using a hypothesis test. I want to prove a difference. I want to prove that the correlation is not 0. If the correlation were 0, it would just be a cloud of points. But I want to prove that it's not 0. So then, what does the statement rho equals 0, what does that actually mean? And what does it mean when rho does not equal 0? What's the meaning of those statements?
Rho equals 0 is no relationship.
Okay. And specifically in this situation, it would be there is no linear relationship. Okay. Now, Jessica, you're actually on restrictions, so you're not supposed to be answering questions. But... So then what does it mean if rho is not equal to 0?
There's a linear relationship.
There is a linear relationship.
Positive or negative.
And it could be positive or negative. A positive or negative linear relationship. We are wanting a data-driven decision. We want to know if there is a relationship between these things, and we want to use data to prove it. And so if we're able to prove it, then we're able to say that there's something about this that makes it into a relationship, a linear relationship. What would be the words you would use to describe a positive linear relationship between X and Y? What sentence would you say if there's a positive linear relationship between X and Y? What would you say? No, I'm looking for what does it mean to be positive? What is the positiveness of the relationship?
As one increases, so does the other.
As one increases, so does the other. As X increases, so does Y. So, Gabby, what's the negative relationship?
As X increases, Y decreases.
Okay, as X increases, Y decreases. That would be a negative relationship. Okay, so those are the things we want to find out. What happens when I put more guns into a neighborhood? Does it change the situation? What happens if I put more folic acid in the milk or the cereal? What does it do when I put folic acid in the cereal? Does it change anything? Well, if I'm going to have data that's going to tell me something, then I should actually have a way to say this goes down or this goes up. That's what I'm trying to do. That's what I'm trying to figure out. What happens when I do something? Does it change something else? Or are there two things that are related to each other? If you have more magnesium in school lunches, will it change the grades of the students? I don't know. But this would be a way to at least figure out maybe if we can find out. Maybe. All right. So this correlation. What's the next thing that we want to do? What else do we do besides correlation? Regression. What is the question which is answered by regression? What is the formula? So then when we ask the question, what is the formula? We're going to come up with something that's either going to look like this, y equals mx plus b, or it's going to look like this, a plus bx. And usually we say y prime here. And the number which is in front of the x is the slope. Which is telling us the rate of change. It's telling us if x increases, does y go up or down? That's what the slope tells us. Now the intercept, the other number that we have, is not really meaningful for us, so we're just kind of going to leave it alone. So far, we reviewed stuff here now. What else did we talk about last time? Besides correlation regression. We talked about confidence intervals. What else? Prediction intervals. What else?
Coefficient of determination,
Coefficient of determination, and what's the symbol for that?
R squared.
R squared. And sometimes we use a capital R for that. Sometimes we use a small r for that. Depends on the software, the textbook, or whatever. Okay. Yeah, I guess I'm going to have to leave my restrictions alone here for a while. Although those of you that answer all the questions all the time, just, you know, how can I say this? What is it? When you, like, if you're a comedian and you go out there, you've got to know your audience, all right? So know your fellow students here. So if you answer all the questions, then that means other people don't get a chance. So you have to kind of limit yourself. I'm going to put that on you now, and hopefully you can. All right. What does the confidence interval tell us in this situation? We're doing two variables. We have a confidence interval. What does the confidence interval actually tell us?
What data values of y to expect for specific x?
No, that's not the confidence interval. Alex?
Predict the population mean of y for a specific x value.
Okay, so we're finding the population mean of the y for a specific x value. Crystal, what about the prediction interval?
What data values to expect?
For a specific y value. Or x value, sorry. So, Sierra, I think I'll have you answer this question. Does y prime tell us what's going on? No. What is it that tells us what's going on? The prediction interval tells us what's going on. Because the prediction interval is telling us what the data values are that we're expecting to happen. Y prime, which is the equation of the straight line, does not tell us what's happening. The prediction interval tells us what we expect to happen. Okay? So, in most situations when people do research, they don't include the prediction interval. because many times it doesn't actually tell you what you want to know. You think you know something, but you don't, Nemo. And so then you have this thing and you think that the straight line is telling you what's happening, but it doesn't. The confidence interval even does not tell you what's actually happening with the data. It just tells you about the average. The prediction interval tells you what's going on with the data itself. Most of the time they don't put that in when they put a research thing out there, because a lot of times it doesn't work. So, well, whatever. All right. So the confidence interval measures the mean or the average for the population given a specific X value. But it's limited because it doesn't tell us what data values are going to happen. The prediction interval is better to actually know what's happening. All right. What about R squared, coefficient of determination? What is the meaning of R squared?
Of the strength of our production.
Okay, this is the strength of prediction in percent. So this is all nice and theoretical. So now we're going to see how this actually works based on our assignment number 15. So hopefully you've had enough discussion with your friends and neighbors to get this all cleared away, to know what's going on here. So I have information about cars. The X variable is the weight of each car, and the Y variable is miles per gallon in city driving. So I'm looking at this linear situation. What's going to happen right now is I'm going to talk about what this actually means, and then we'll try to answer the question. Okay. So when I'm looking at this, and I say, is there a linear relationship? And I think about doing a hypothesis test. I've got a correlation here of negative 0.88. Would we consider that to be relatively strong? Okay. And we have an R squared of 77%. So yeah, it's relatively strong. How would we describe this in a phrase if I know it's a negative correlation? What does that tell me about the relationship? Can someone describe for me, if it's a negative correlation, what is that telling me about the tendency? I want the meaning of the fact that this is negative. Casey, can you tell me? Okay. Hillary, can you tell me? Okay, and then specifically for this situation, what does that mean?
As the weight of the car increases, the gas mileage goes down.
Okay, so as the weight of the car increases, the gas mileage is going to decrease. It's going to go down. Does that make sense? All right. I didn't always know that, but it does make sense. The heavier the item, the more gasoline it's going to take to move the thing around. So yeah, makes sense. However, when I look at this and I say, is a straight line the best option here? Because when I look at the straight line, it does seem to kind of go through a lot of the points. But if I think about it, a curved line might be better. And so then what I did was I had software that created a curved line. And now I'm going to ask the question, is it better? And how would I tell? Lena Schmidt, can you tell me what did you answer for that?
For the curved
Yeah.
graph, I said the R squared value indicated for the graph is higher for the curve versus the linear
Okay.
graph, and that means the strength of prediction is better, and you get a more accurate representation of the information.
Okay. So if I look at the curve and I say the R squared went from 77 to 88, then that would be an indication that it's better. It's a better predictive thing. But that's not the only thing I might say. Does anybody else have any other reason why you might want to say that?
The correlation is positive.
Well, no, not really, because this is a complicated equation. The meaning of the correlation doesn't have quite as much in there. Anything else besides the strength of the R squared?
Because the correlation is closer to 1.
Well, but if the correlation is closer to 1, that makes this stronger too. So it's the same thing, really. Is there any other reason why you might say that the curved line is better than the straight line? Okay. Especially when you're talking about the confidence interval, which is the blue part here. So the blue part here, it has this big section where there's no points in it, okay? But over here, it seems like it's going through the points more clearly. So that would be another good reason why we would want to do a curve. So those would be reasonable answers to this question. It's better because it fits the points better. And that means that R squared is closer to 1 and it's a stronger thing. What did I say was necessary when we're going to use a curved line? Can somebody tell me what I said you're supposed to do if you're going to have a curved line?
A specific reason to do it.
You would need to have a specific reason to do it, okay? And the fact of the matter is, when you talk about miles per gallon, that's a pretty complicated scientific thing, right? To know how that works. And so you would say, well, it kind of makes sense if it's not just a straight line, because, you know, you've got a lot of chemistry and engineering and all this other stuff that's involved. And so there's nothing in the situation where we would say it has to be a straight line. So it seems like a curved line might make sense. Now notice, however, does this curved line go through the middle of the points? Why would I say no? If I'm looking at this collection of points and I say this curved line does not go through the middle of the points, why would I say no? Well, this section right here, all the points are below the confidence interval. So this is not going through the middle right here. It's going through the top. All of these points are low compared to this line right here. The line is supposed to be predicting the average. Well, if it's predicting the average, then all of these things are below average. That just doesn't make sense. So there's something about this that isn't exactly right, because this right here, it's not going through the middle of this set of data. I don't know what it is. I'm not an engineer. But there's something going on here which just seems a little fishy. That when we get to this point right here, all of the data is below the middle. You can't have things that are below the middle all the time without saying there's something going on here. And again, I don't know how it works, so I don't know what's going on. But it just looks a little fishy. And certainly that's the case here. If I draw a straight line through these points, there's a huge amount of these points that's just all below the middle. And so that just seems to indicate there's something going on here that I don't understand, which is actually affecting these points right here. They're all, yeah, something's going on. I don't know what, but it just looks a little funny. All right, so that was question, or part A, I should say. So what you should have is the explanation of why it's more appropriate. You should not just have a yes or no answer. You should have an explanation. Okay? Any further questions on part A at all? Okay. Just another thing I wanted to show you here, and that is when it does the equation, it doesn't use X and Y. It actually puts in the name of the variables. So miles per gallon city is equal to 50 point something minus this number times the weight. So this is the Y value here, this is the X value over here, but it's actually using the word. And the p-value here, remember when we talked about p-value, we said if p-value is less than alpha, we reject the null hypothesis. These are really small p-values. Does somebody know what this means?
One times 10 to the negative 4.
1 times 10 to the negative 4th, which means it's 4 decimal places away from where it's the 1. So when you see this capital E in some kind of computer thing, and it has a negative number out here, that means the number is very small. All right, so far so good. What else? Oh yeah, there's a second one. All right. So now we have each of the United States. And we're going to find out if there's a relationship between federal spending and vehicle theft. What does this say here? Alyssa, can you answer number 1 for me?
I already said as the federal spending and the state increases, more theft increases.
Okay, and how did you come to that conclusion?
Because it was positive.
Okay, so we have a positive correlation and we also have a positive slope. Okay, as you can see here, this is the equation. Y equals this plus this times X. So this is the slope, which is positive, and the correlation is also positive. So who can tell me why that might be true? If you have more federal spending, why would you have more theft of vehicles? Do you think the federal government is paying criminals to steal cars, or? Probably not. So I'm asking you sociological people out there. what would be something that would have more federal spending and also more vehicle theft?
For neighborhoods, because of like food stamps.
Okay, if you have different poverty programs that are helping people, then there might be more crime as well because people don't have a lot of money. Now, as it turns out, that's not always true, but it might be true. And that's what we're going to try to figure out. So let's determine or interpret the R squared. Liz Stanish, can you interpret the R squared for number 2 here?
I said that R squared in the study is very weak at 10.42%.
Okay, so it's a very weak R squared. And so that's telling me what?
That a weak correlation exists.
Okay, there's a weak correlation exists, and then, that's correct. So I'm gonna open this up to anybody. What does that mean when we say a weak correlation exists?
That it suggests that federal spending is not large predicting faster motor stuff.
Okay, does that make sense? Does it make sense that federal spending does not have a lot of impact on vehicle theft? Laney, you say yes. Why do you say less? Yes.
Well, because like she said before, I mean, I don't see, I mean, in the graph, there's a strong correlation between.
Actually, no. In the graph, there is a correlation,
I'm
but it's
sorry,
not
there
strong.
is a correlation, but according to R squared, it's just a weak correlation, but I don't know. Yes,
Okay, so why would we say it's weak? I mean,
it's only at 10.42%.
that's correct. But then in terms of our understanding of the relationship, what is it about federal spending that makes it not very strong in relation to vehicle theft? The basic idea is there's a lot of other reasons why people would steal cars, all right? The fact that they would live in a particular neighborhood, which gets federal money coming in, I don't think that really makes that much difference in whether somebody's going to steal a car or not. And so it's only 10%. So it's not a big thing. If you want to explain why are motor vehicle thefts high or low, federal spending is not going to help you a whole lot. Okay? So right now, as of right now, we don't know, or we know that it's not strong. How about that? We'll say that. We know it's not a strong relationship. Although it does come out to be, in our hypothesis test, it does work. Because, and we'll do this more later, but this 0.32, this would be in the rejection region. So yes, there is a relationship, but it's a weak relationship. Okay. So now, the payoff, as they say here, we want to find confidence intervals and prediction intervals for different x values, right? Let's see. Caitlin, do you have numbers for me for number 3? All right. Mattia, you got numbers for me, number 3? All right. Mara, you got numbers for number 3?
Yes.
Okay. Somebody got numbers for number 3? Christina, you got numbers.
I'm gonna be wrong, but
Okay.
I'm gonna go for it.
All right.
So I got 0 and 12.
So these are confidence interval for x equals 7.3. And you have from 0 to 12. All right. That's pretty close. All right. Now, how about 17.3? Christine, you got those?
For the next one,
For the other x value?
negative.
Nope, sorry. I'm looking over here for confidence. Okay. Minan, you have those numbers?
No.
For the second part? Okay. Who's got numbers for me for the second part of it?
13 is a little less than.
13 to what?
36.
36? Okay. Now those are approximate, right? But close enough. Now the question is, what are we talking about here? What does the confidence interval tell me? In this particular situation, what is it predicting? Someone tell me what this is predicting.
There could be between 0 and 12 motor vehicle deaths.
Not correct, no. What is this predicting? Emily, can you tell me?
On average, if there is 17 or 7.3 thousand federal spending dollars spent, there will be 0 to 12 motor vehicle deaths.
Okay, the first words that you said were the ones that we need to have, and that is
Average.
the average, or the population mean, is between 0 and 12. So this says, if I average all the states together that have 7.3, I would get between 0 and 12. And the same thing is true down here. This is telling you where the population mean would be. Now here comes the crazy question, Emily, since you're able to answer that question. Would you interpret this to say that there is a difference between a state which has 7.3 and a state which has 17.3?
Yes.
Okay. Because these confidence intervals are separate from each other, we would say that if a state has 7.3, not one state, but all the states with 7.3, the average there would be lower compared to the average over on the other side. So it looks like states, all the states that have a high amount of federal spending, their average is higher, and the states which have low federal spending, their average is lower. So it seems reasonable that we would say more federal spending means more vehicle theft. It seems reasonable right now. But as I said, the confidence interval does not actually tell you what's going on. So just by looking at these numbers right here, we could say that they are reasonable numbers based on the fact that it could be you've got an average from 0 to 12 or from 13 to 36. That could happen. However, we are now going to look at prediction intervals.
Before we do that, the way to write the confidence interval, would that be 0 is less than mu of y, which is less than 12?
Yes. Or you could say the population mean of y is. Okay, you can use symbols or you can say words either way, right? But now we want to do prediction intervals. Alex, you got prediction intervals for me?
Negative 20 to 32
Okay.
for 7.3.
And then for 17.3?
Negative 2 to 52.
All right, and these are approximate, of course. So Alex, are these reasonable?
They're unreasonable.
Why are they unreasonable?
You can't have negative cars or negative stuff.
Okay. The only way that this would work is if the criminals were building cars and handing them out to people, which they're not. Okay, so it doesn't work for us to have negative numbers here. What that is telling us is that what we have done up to this point is not legitimate. The things that we have been saying all along here don't work. Because when we try to use the prediction interval, it's giving us negative numbers. So that makes it unreasonable. So that means everything about this up to this point, which we have said, is unreasonable. There is not actually good evidence for this relationship. There is not actually good confidence intervals for the vehicle thefts. And the reason why is because this selection of data is not bell-shaped. Why is it not bell-shaped? When I look at this data set, how would I say this data set is not bell-shaped? And what I mean is, for each x value going like this, do I have a bell curve or do I not? And I say I do not. Can someone explain to me why I do not have bell-shaped data?
There's more data above than, or below than above, or the opposite, above than below.
Okay, there's something going on here. Here's the mean right here. Here's the confidence interval for the mean. This is where I would expect most of the data to be. If I look right here, this is where most of the data is, right here. I have maybe some tails up here, right? But I have no tails down here. This section, there's nothing there. Why is there nothing in this section? Because I can't go below 0. So this whole section right here, there's nothing because I can't go below 0. So this data, if I were to graph this data going like this would be right skewed because I can have data values which are way up here, but I cannot have data values way down there. So this is not bell-shaped data. Since it's not bell-shaped data, I should not be using correlation and regression with this. Because the mathematics doesn't work if the data is not bell-shaped. This is not bell-shaped. So I should not be doing correlation or regression with it. And one way I can see that I should not be doing that is because I came up with these negative numbers up here for my predictions. So, once again, when I did the straight line, I was able to prove my hypothesis test. When I did the confidence intervals, I was able to see that the confidence intervals could be true. But when I do the prediction interval, I see that it doesn't work. And then when I actually look at the graph, I see that my data is not bell-shaped. So it makes it so it's not working. It's bad. It doesn't work. It's not reasonable. Okay. All right. Now, I suppose we'll come back to this, but yeah, we'll come back to this later. All right. So as it turns out, since we're going to have a test on Tuesday, I don't know if you saw that. The exam is coming up on Tuesday, so I'm just going to allow you to keep your homework. So you don't have to turn it in. And so the fact that you're here today is good enough for me. So I'm going to call that turning in your homework. Since after all, we went over it, every question, gave all the answers. Hopefully you wrote everything down. So that's good. All right, so we're going to take a break for 10 minutes. Then we're going to come back and review for the test, because that's the next thing that's going to happen. Oh, and by the way, if there's anybody who's not here, yes, they can turn it in. Okay. But if you're here, you don't have to turn it
We do not have our last test yet.